Continuing with the discussion of the home bias in portfolio choice, we have these two expressions from the last video. Okay, so again, what these say is that in every state S, so the conditional on the state, these expressions have to hold, okay, state by state. And then in addition to these two equations, we have two more equations. So these two equations come out of the microeconomics, out of the solving the consumer's problem and the budget constraint, things like that. And then we also have the resource constraints. So this is very typical for like equilibrium conditions. And what we're saying here is that the total amount of home good either consumed in the world or paid in trade costs has to be equal to the endowment of the home good. That's the only amount of home good that exists in the world in every state. So again, how much of the home good, another way to say it, how much of the home good is consumed in the foreign country? Well, it's the part of the home good that's not consumed in the home country, plus the part of the home good that doesn't fall off the ship on the way to the foreign country. Okay, so that's how you understand this constraint. And we have a similar constraint for the foreign good. So we have four equations and four unknowns. Okay, and if you tell me the parameters here, and you tell me the trade costs there, these are just, and then also of course state by state, right? So you have to tell me what were the two endowments in this particular state. I can tell you exactly how much will be consumed in each country. So I've got a CF, I've got a CF star, I've got a CH, I've got a CH star. Looks like I probably should put these stars in a consistent place here, but oh well. For the rest of the discussion, we're going to assume that 1 divided by 1 divided by theta is equal to rho. It's not essential to do that, but it makes the algebra a lot easier. You can see why just by looking at this equation. If 1 divided by theta is equal to rho, then this power goes away, and it makes everything easier to solve. That's all. Okay, so I'm not going to do the solution, but if you want, you can actually go through the algebra. It's not that difficult with that assumption that 1 divided by theta is equal to rho. But it gives you this solution. So state by state, here we're only looking at home. State by state, home is going to consume this share of whatever the home endowment is. Okay, so this share is somewhere between 0 and 1. And then the rest of the home endowment is of course going to be consumed by foreign, the part that doesn't fall off the ship, right? And then here, how much does home consume of the foreign good? Well, it's going to be this share, which is somewhere between 0 and 1, of the foreign good. And then you can see here, I didn't say that thing about falling off the ship. So when we think about how much of the foreign good does home own, actually, it's going to be more than what it consumes, right? This is what it consumes, but it has to actually sort of own more than what it consumes, because the foreign good on the way to home, some of it's going to fall off the ship. Okay, and that's actually kind of the important point here in this model. So this XHS here is no longer consumption. It's what home owns of the home good. And it turns out that that's going to be, in this case, the amount that home owns of the home good is going to be identical to its consumption, since there's no trade cost. But the amount that home owns of the foreign good is going to be more than its consumption. It's going to be the consumption divided by 1 minus tau. So you can see if we divide this expression up here by 1 minus tau, we get this expression. Okay, so maybe I could just write it here. Divided by 1 minus tau is equal to. Okay, so let's notice here. So far what we've talked about is what happens state by state. Remember, we're talking about these arrow-to-row securities where what happens depends on what the state is. But it just so happens that with the arrow-to-row securities, the optimal solution here is that no matter what the S is, no matter what the state is, home is always going to own this much, this share of the home good. And no matter what happens, home is always going to own this share of the foreign good. Okay, so these shares are independent of the state. So in a sense, we can actually implement this. Let's see what I wrote here. Okay, I just wrote what I just said. We can actually implement this Arrow-Debreu solution using a simpler instrument. So we don't actually have to contract state by state, since the home share of the home endowment is the same in every state, and home share of the foreign endowment is the same in every state. We can think of it as though home actually owns sort of a fixed share of, the home endowment. In other words, it's like a stock. It's like an equity. Home owns a particular amount of, the output of the home firm. And it doesn't matter what the state is, it always owns a certain share. So that's not quite as flexible as this Arrow-Debreu security, but in this particular case, it turns out that it's equivalent. So that's how we're going to think about it. Okay. So I've written here, you can think of this optimal share as a stock in the home and the foreign endowment. Okay. Moreover, since home and foreign are symmetric, the price per share, remember these are world prices, right? We're facing these, it's not a different price for home and a different price for foreign. These shares are traded with no trade costs. There's no cost of trading portfolios. So the price is the same in the two countries. Moreover, since the two countries are symmetric, the price has to be the same. Okay. So therefore, I write, the domestic portfolio share is this expression here. And where did I get that? It's it should be 1 divided by 1 plus minus tau theta minus 1. I added this to the slide today, so let's hope I did it correctly. For 1 plus, yes, 1 minus tau theta minus 1 divided by 1 plus 1 minus tau theta minus 1. Okay, yeah, that's correct. This thing goes away. So that is correct. If you just work it out, you'll see. If you just take these two, so what did I do? Okay, let's just take this. All you got to do is just take this expression and then divide it by this expression plus that expression. That's what I did. So let me write it out more clearly. So that is 1 divided by 1 plus 1 minus tau theta minus 1 divided by, now I'm going to not skip a step here, 1 divided by 1 plus 1 minus tau theta minus 1 plus 1 minus tau theta minus 1 divided by 1 plus 1 minus tau theta minus 1. Okay, and what you'll see is that this term on the bottom just turns into 1. So you're just left with the term on the top, and that is what I wrote here. Okay, so that's how we got this domestic portfolio share. Okay, so one thing to note is suppose that trade costs are 0. If trade costs are 0, what do we get? Well, this tau here is equal to 0. So we're going to have 1 to some power. 1 to some power is just 1, so we're going to get 1/2. So if there's no trade costs, then people invest half of their money at home and half of their money abroad. Okay, that actually makes sense in this model because it doesn't have that weird labor shock thing I was talking about. There is no labor shock, there's just an endowment. So full risk sharing implies that people invest equally as much abroad as they invest at home. When we add trade costs, though, that's no longer true. So if we plug in trade costs here of 0.25, so it means 1/4 of the goods fall off the ship on the way over, and then we put in a theta of 6, which implies, let's see here, 6 divided by 5, a 20% markup, which is in the realm of reasonable profits in a CES world. Not exactly in this model, but something that people use in this sort of class of CES models, so a reasonable parameter value there. Then what you end up with is that this domestic share is 80%, which is pretty close to what you see in the data, right? We saw that in like Germany and the UK, you had about a 20% foreign investment share. So, this model doesn't do a terrible job of explaining why people invest more at home, and it purely depends on trade costs. This is actually probably the coolest part of the paper, if you ask me, is that it highlights this mechanism that isn't so obvious. But basically what it says is, if you're risk sharing, since you actually have to pay a trade cost when you import goods, it's not actually so attractive to invest in foreign companies, at least if they're manufacturing companies. So yeah, so that's kind of it for this puzzle, the home bias and portfolio. So I'll stop the video here and we'll move on to the other three puzzles.